going to be 0. So here what is going to happen is, so you want to do the same thing, minus 1, 1 minus lambda, then you add this here, right? So if you expand this one, so this is minus 1 by 1 by lambda. So if you do this, it is going to be lambda square minus lambda minus 1. So we know this is the characteristic polynomial, and we equated this to 0. So this is also going to be 0. So this is 1 minus lambda 1 0 0 x1 x2 equal to 0, right? So you do the multiplication here, 1 minus lambda x1 plus x2 equal to 0. So if we solve this equation for x1 and x2, then x1 and x2 is the eigenvector. So again, I did not substitute the value of lambda here because I want to keep it as a constant, because this lambda value, the eigenvalue, is 1 plus or minus square root of 5. It's going to be a fraction, it is going to be messy. So I'm going to keep that as a lambda just to simplify the derivation. So here it is 1 minus lambda x1 plus x2 equal to 0. So let us put x1 equal to lambda. Again, you may ask why I'm putting x1 equal to lambda. I can pick other number or other constant, whatever. So again, I'm trying to make this equate to the characteristic polynomial what we had, because we know the value of that. So I'm trying to put a value such a way that it will be equate. It will equate to the characteristic polynomial. So x1 equal to lambda. So 1 minus lambda plus x2 equal to 0. Then it means lambda minus lambda square plus x2. So now this is the form of the characteristic polynomial. So this is going to be 1, right? Again, I should have wrote that characteristic polynomial because I'm trying to use it as much as possible here. So this is going to be 1. If this is 1, then we know it is going to be 0. So x2 is going to be 1. So the eigenvector is going to be lambda and 1. So this is the eigenvector. So maybe I will write down this eigenvector. So S is equal. It's not. Yeah, it's S actually. But I'm not writing in a correct form. But just to store it somewhere so we can reuse it. Okay. What is the purpose of doing the diagonalization, right? So basically, we found a way to write this matrix A in the terms of eigenvalue and eigenvector. So this is the eigen value which are going to be in the diagonal of this matrix. This is the eigenvector and this is the inverse of the eigenvector. So when we talk about A to the power k, then we are talking about S lambda S to the power, S inverse to the power k. So when we say to the power, we all know what we mean by that, right? So basically we have to multiply that k times. So basically we have to multiply this for the k times. So if you see this, so S inverse, yes. So you will have S inverse, yes. So you will see S inverse, yes. So this all is going to be identity matrix, right? So S, so here there's an S here, there's an S inverse here. So see lambda, which is going to be k times S inverse. So that equates to S lambda to the power k S inverse. So basically, this AK can be written as S lambda to the power k S inverse. So I'm going to do that to this. So UK is equal to S lambda to the power k S inverse, then U naught, right? So this S inverse, yes. First I think I should write the S in a complete form. So here lambda 1, lambda 2, right? So the S inverse So this is lambda 1 by lambda 2. Change it. I mean basically change it and change the sign here, right? So minus lambda 2 minus 1 lambda 1. Right, this is what the S inverse is. So then this is equal to, U naught is 1 0. So if you do this, if you do this multiplication, lambda 1 over lambda 1 minus lambda 2. So if you take this, it basically 1 minus 1, right? So this is a constant, so I'm going to keep it because I'm not going to multiply it just to make my calculation easier. So 1 by lambda 1 minus lambda 2, then S lambda to the power k, then this is, let us say this is C. C is basically this, right? So now let me take a lambda. Maybe I should store C also here, just to. Okay. AK, and I should write UK. UK is equal to S lambda K C, and S is lambda 1, lambda 2, sorry, 1, lambda 2, 1, and again I had this constant outside, right? So lambda 1 minus lambda 2. So you have this eigenvalue in the diagonal, right? So to the power k, 0, 0. This is 1 minus 1. So you multiply this one, lambda 1 by lambda 2, lambda 1, 1, lambda 2, 1. Do this, lambda 1k, so minus lambda 2 to the power k, right? So take this 1 by lambda 1, 1 by lambda 1 minus lambda 2, do this multiplication, so this is k1, k plus k to the power 1.